Okay, good afternoon, everyone. So let's get started. We will continue our discussion from the last class, and we will consolidate the ideas that were introduced in the last class. That's the plan for today's session. So in the last class, we have introduced this idea of associativity. So here is an example of associativity. So, subtraction operation, addition, multiplication, division, these are all left associative. So if you look at this statement A minus B minus C, so since it is left associative, first we compute A minus B, and A minus B is 1 minus 2, 1 minus 2 is minus 1, minus 3, which is equal to minus 4. But on the contrary, if it is right associative, then you may end up computing something like B minus C you compute maybe to start with. And so you will get a different answer, but that's not the way to think about it. This is the right way to think about it. So, but usually, important thing is all the associativity properties take care of things. It is very important when you write programs that you don't rely on these operator precedence and associative properties given by the language too much, because you can end up making mistakes and introduce bugs in the program for no good reason. If what you meant is A minus B minus C, the best way to write it is this. You do A minus B, after that minus C. This is the best way to express the expression that you have in your mind. So keep this in mind. So just because, initially when we are learning programming language, we would like to use the language properties, all these things nicely, and want to write maybe smaller programs, things like that. But forget about all those things. What is most important is code readability, as Pratyaksh rightly said. So you have to try to, as much as possible, specify the expression that you have in mind nicely. There is a question, does parenthesis affect time of compilation? Uh, Negligible time, Varshita. It is true, every character that you add, etc., it will have some effect on compilation time, but it is negligible. You don't see any difference. So don't worry about compilation time, because code readability is what is more important than compilation time. Because when you build software, when you go to companies and build software, or when you contribute to open source projects, so code readability becomes important. The code that you have written, someone else is going to read that code and understand what you did and try to improve upon it. All right. So if you see, let's compile this code. This is GCC associativity.c.a.out. So as expected, we have -4 is what we got. But this is not a suggested way to write the code. The best way to write the code is, this is A minus B, put it in parentheses, and then use minus. Great. So now let's look at one more new syntax feature. So here, so this is what is called as a prefix decrement operation. So let's say here on line number 7, I is initialized to 1. So when we have minus minus I here, this is what is called as a unary operator. So this is a unary operator. So minus minus I means decrement the value of the variable I, and after you decrement it, whatever the value it is, you pass it to the printf function. So here the value of I initially is 1, and when you decrement it first, you get 0, and 0 is passed to printf, and 0 gets printed on the screen. And on line 9 again, so when you print I, the value of I is updated to 0, so you just print 0. On the contrary, so you have on line 12, you have what is called as a postfix decrement operation. In postfix decrement operation, you first use the value of I. So the value of I initially is 1, and then you decrement it, so it becomes equal to 0. And then on line 13, when you print it, 0 gets printed. Right? So let's compile this program and see what happens. So here, that's what as expected. It is 0, 0, 1, 0. So that's what is expected here. So this is called as postfix increment, and this is prefix, prefix, or yeah, it is you first increment. So on line 8, you first decrement and use the value, and on line 12, you use the value of I, and then you decrement. So similarly, just like you have minus minus operator, you have plus plus operator also. So let's say if it is plus plus I, and can you tell me what will be the values here? If I change this here, what will be the values printed on the screen? Can you think about it? 2, 2, 1, 2. Yeah, good. You got it. So let's compile this program. GCC incr1.c. You can see 2, 2, 1, 2. Excellent. So you're all with me here. Now let's look at one more program. Great. So what will be the output of this program? On line 7, we are initializing I is equal to 2. And on line 8, so without compiling the program and executing it on your machines, what will be the output of this program?
3 and 4.
3 and 4. Great. So 3 and 4, 2 and 6. Okay. Let's compile and see what do we get. This program is INCR2. So you are getting 3 and 6. Good. So the reason why we are getting 3 and 6 is, again, operator precedence is important. Like for example, this plus plus operator or minus minus operator has higher precedence than multiplication, right? So because of this, this will be evaluated first. Okay, but then since it is postfix, okay, since this is post, so what happens is the value of I is equal to 2 is first used, and then 2 gets incremented and it becomes 3. The value I becomes 3. So here the value that we use here is 3. 3 times 2 is equal to 6. And then when we print, so the value of I is 3 and the value of j is 6. So 3 and 6 will be printed. The important idea here is this unary addition, this increment operation has a higher precedence than multiplication operation. Again, the important thing is you should not be writing code like this. This is a very bad code, I would say. If you want something else, then what you should do is I is equal to, the best way to write this code is to go here and say I is equal to I plus 1 and then do something about it. So whatever the logic that is required, you can insert before, but writing this piece of code where it very much depends upon the operator precedence and language rules is bad. All right. Also at this point, I would like to say There are many rules on operator precedence, left associativity, right associativity. If I go through all those rules, you get bored in the class. So I'm just giving you the most important ideas. And if you take a look at the book, all these precedences, which operator has higher precedence than which operator, they are nicely summarized. So you should look at the book. You will get the book, guys. Keep your fingers crossed. I am also keeping my fingers crossed. Can you try printing plus plus I plus plus on the same line? Let's see. What do you want? So let's say I is equal to 2. Plus plus I plus plus. So what do you think the value will be? What will be printed when we run this program? 332. Three, 3, 3.
So but there are only 2% D.
Okay.
So
Okay. I'll take care of this. Someone raised a hand. Let's see. Yeah, someone raised a hand. You can enable yourselves, unmute yourselves and talk. Shubham, I think. Okay. So let's see. Let's compile and see what happens. This is a nice question. I don't know why whoever asked that question. I forgot who asked this question. Let me see. Who asked this question? This is a nice question.
Sir, Ayush asked.
Okay. So let's compile this. GCC incr3.c 442. Interesting. So yeah, there is a reason I would have skipped to answer this question, but there's a nice point I wanted to illustrate here. So because of that, I took up this question. When we are passing parameters to functions, these parameters will be evaluated from right to left. These parameters are evaluated from right to left. So the rightmost parameter or the expression is I plus plus. So this will return 2, and then after that it will increment, it gets incremented. So I becomes 3 here. By the time I is evaluated here, it is 3. Here, is this what we got? Let's see, this is my understanding. And then after that, this becomes, this should be 4. It should be 432 should have been printed. But what it printed different, it looks like, what is it? It printed 442. Interesting.
Sir?
Oh, yeah, someone has a question.
No, sir. I was just going to ask. Maybe it evaluated only the unary operations right to left, and then printed.
Oh, is it?
I don't know. I'm guessing.
You're guessing. So,
Sir,
yeah.
I think that when it prints the value, it will print after it executes all the I plus plus I and plus plus I. So, like after
No. Not like that. The values will be passed as parameters to printf. So the thing is, if I thought since the parameters, if I remember that parameters are evaluated from right to left in C. So the rightmost one,
So
it is
maybe
taking
it
2.
so maybe it first evaluates everything and then prints all the outputs or something like that
Yes, sir.
to
It
give
could be
444.
It could be true. It could be true, but yeah, we have to check. So this is a homework problem for you. Please help me explain. Based on my language understanding, I thought we should be printing 432, but someone has a better explanation. Please. There are some hypotheses. They are valid hypotheses, but what does the language manual say? We have to check. Anusha has this question, does it evaluate before passing the parameters? Yes, yes, it has to, the values, whatever the values that are returned, see what happens is each of these things, these are expressions. So the values that come out of these expressions will be passed as parameters to the printf function. All right. Okay, so very good question. So homework problem for you. Please figure out a valid. So there are good hypotheses, but I want a proper reference saying no. So the language manual says this, something like that. So that's what I want. So that like if something new, the explanation that you have may work for this statement, but it may not work in some other case.
So
All right.
I remember reading somewhere that the evaluation order in the printf statement depends from compiler to compiler.
It can, is it the case?
Yeah, I remember reading that somewhere.
Okay,
Yes,
I'm
it's
not sure.
compiler implementation dependent.
Uh-huh.
So mine is giving out 5, 5 and 3. I took I equal to 2.
So mine is giving out 442.
Oh, is it? So who?
442.
That's why.
It's compiler dependent. Huh? So
442 here as well.
Which compiler are you
442.
using?
Okay.
Even
I'm
So,
compiling it online.
442 only. I did the same thing on C++ and I got the same
awesome.
thing.
So 442,
442.
552, some interesting answers we are getting. So there is also someone is claiming that it depends. It is compiler dependent. What is the moral of the story? The moral of the story is
Don't
don't
use these
write code which is
operators.
compiler dependent. So it cannot be, the output cannot be compiler dependent. Imagine that, like in the exam, so you tested all your code and then you submitted it to the TA, and the TA runs it on his machine and it gives a different answer. So it's bad. So, but that's a very easy fix. You can go argue with TA. It worked on my computer, etc. But you write your code and you launch it on Mars or on some rocket. You cannot say sorry, you used a different compiler, or so you have to be very, very careful about these things. All right, so I think we should move on. So it looks like like in the some different students, when they are trying it on their own machines, we are getting different answers. So it looks like it is compiler dependent. I'm a bit surprised. But what I would say though is we should not be writing code like this. Okay, we should never write code whose behavior depends on compiler. That's number one. Even if it is not compiler dependent, so when someone looks at this code, although the output is the same, no, it's not compiler dependent. This is a bad piece of code. We should not be writing code like this. Great. Let's move on. We have a lot more things to look at today. So yeah, L value. And if you see the textbook, actually, when you read the chapter in the textbook, most of the things in the textbook, the explanation is on explaining how these border cases are handled. So here is another statement, line 12. This is a pretty bad thing because on the left-hand side, you have a constant. I just used a constant to illustrate the idea of what is called as an L value. So GCC L value dot C, and you can see the error is L value required as left operand as a of assignment. So on the left hand, on the left side of equal to, we need to have what is called as an L value. A variable is a valid L value, but a constant is not a valid L value. Like that, there are a bunch of valid L values. Later on, when we learn about arrays, you will see array expressions can be L values and things like that. So there are some valid L values, and there are some L values are not valid. So, but what is an L value? You need to know. That's the purpose for which I used this. I'm showing this code. It is not L2. It is 12, Aditya. Okay, so if you, yeah, 32. Let's make it 32, and you will get. So in this context, I want to say one interesting bug which my professor told when I was doing my BTech. He wrote some program for his PhD thesis. In those days, you know, in computers, 0 and O look very similar. And in some place, he was using O instead of 0 or something like that. And so because of that, it is all, his program is not working. It is working incorrectly. And it took him quite a few months to realize that he is using 0 in the place of O or the other way around. So it's an interesting bug. Now let's look at one more piece of code. What will be the output of this program? Yeah. So what happens in this code is, see, in the case of one important idea that I want you to understand is the assignment statement itself returns a value. And when there are multiple assignments, the whole of this assignment is treated as an expression. So first this assignment happens, this is right associative. Assignments happen in a right associative fashion. So first integer I is assigned the value 33.3f. And since I is an integer, the fractional part is truncated, I stores 33. And then whatever the value that is present in variable I, it is copied into the variable f, and f is a floating point number, but but the value that is present in I is 33. So 33 gets copied to f, and so when we print, it will be 33 followed by 33 point all zeros. So let's compile this program. So GCC assign1.c. Sorry, this is not assign1. Oh, yeah, this is assign2. So GCC assign2.c. We compile it. So 33, and there is a question, can we equate two data types? No, it's not possible to equate two data types. We can move from one domain to another domain with loss of information. Like for example, here we are moving from the floating point domain to integral domain with the loss of information that fractional bits are not stored. It gets truncated, the fractional part is truncated. So what happens is, just want to, I'll explain this because, so first this is a left, so this assignment operation is left associative. So that right associative, that means first this assignment operation happens, and this assignment, it does two things. So one thing it does is, it updates the memory of the memory associated with variable I, and the value that gets assigned to variable I is 33. And every assignment operation, it returns a value, and the value that is returned is whatever the value that is returned into this memory location. So 33 gets returned for this as an outcome of this assignment operation, and 33 gets assigned to F. What would be confusing is this. Just want to, there are few questions that are being asked. I will explain. Let's say if you have something like F is equal to I plus 1, this I plus 1 is an expression which returns a value, and that value is copied to the variable F. But what is important is even I is equal to 1, this is also an expression, and the value returned by this expression is 1, and this 1 is copied to variable F, and this again is whole assignment expression, it returns a value 1, and that value is 1, but it is discarded. So there are a couple of students who raised their hands, Rajeshi and Shashwat. Could you please, Rajeshi, can you please go ahead and ask your question?
Yes, sir. Yes, sir. So someone asked in the chat that can two data types be equated? And you said no, it can't be. So I'm not entirely sure about C, but like in Java and all, even if it's like float or int, suppose it's 33 is equal to 33.00, it usually gives this. It usually gives true. So is that the same case in C?
We will see. I will answer that question a bit later. Good question. So we will, because what happens is, I think when you try to do the comparison, the integer gets promoted to float and a floating point comparison happens. But we will talk about it maybe a bit later.
Okay, sir. No.
And what is the other question? So Shashwat?
So here when we are doing I is equal to 33.3f, 33.3 is being converted to integer by truncating the decimal portion, and that is in turn being stored, right, sir?
Yeah.
But sir, suppose in the print f section, if under the quotes I used a placeholder for integer, and after the quotes I send it a float value, it doesn't do the truncation, it just prints a garbage value. So sir, why this difference?
Good question. See, what happens is the way operators work and the way printf works, it is quite different. What happens is in printf, the compiler, whoever what happens is in printf, these parameters are just passed as it is. The string is passed and the value associated with I is passed, the value associated with F is passed just to the printf function, and printf internally deals with them in some fashion. But on the contrary, if you have something like F is equal to, I is equal to 33.3F, the compiler takes care of promoting a floating point number to an integer number by itself. There is a difference between a function call and an expression evaluation. In the case of expression evaluation, the compiler expressions are part of the language itself. Okay, but whereas printf, it's a library call, and whatever the parameters that we have to pass to printf, you just pass them as parameters to printf, and printf deals with it in its own fashion. Does it make sense, Shashwat? I mean,
yes, sir, but had it been designed a little differently, they could have put something inside printf to promote the float value as well, right?
Maybe let's say if you write, it's not possible because the way functions are defined, let's say when we learn about functions 5 classes later, you will understand. So there is a function is defined. So it's like, so there is this function, and function expects some input and it returns some output, that is the return value. When we are calling the function, let's say this is f, and we are calling it as f of a comma b, we just pass a here and we just pass b here, and that is how the semantics of function call is defined. So what we are expecting to happen it may not be quite easy to achieve unless we fundamentally think about the way functions should be handled in C programming language. We will revisit it, but it's a very important question, Shashwat. I appreciate your question, but maybe let's say after 3-4 classes, you will understand why this particular thing is happening.
Okay, sir. Thank you.
Okay, so let's move on. But what I want you to, I don't know how many of you, you're all bound on the truncation, but the thing that I want you to appreciate here is an assignment statement, a simplest assignment statement, such as let's say if I have I is equal to 1, the simplest statement 9 is 9, the statement on 9 on line 9, it is not an, we can call it as an assignment statement, or we can even call it as an expression. And this expression has it does two things. One is it has a side effect. The side effect of it is the memory associated with variable I gets updated, and this whole expression returns a value, and that value is 1. So there are two things that are happening. This expression returns a value just like any other expression such as I plus 1 or 2 star I or whatever. But there is a side effect for this expression, that is the memory associated with a variable, it is getting updated. And the next example that we are going to see is on those lines. So this is assigned 2, this is assigned 1. So if you see this particular example, in this particular example, so what will be the output? Can you guess what is the output for this program when you run it? So what happens here is the value of j here, it will be 1. So 1 plus 1 is 2. I will be I gets updated with the value 2, and the return value of this whole expression is 2. So 2 plus 1 is 3, and k gets assigned 3. So when we print this, the contents of these variables, the value of I is 2, the value of j is not going to change, it is going to remain the same, and the value of k is 3. So 2, 1, 3 will be printed on the screen. Let's run this program. So 2 and 3 is printed on the screen. Great. Nice. Are you all with me here so far in today's lecture? This is the first sync point for today's lecture, because after that we will move on to if statements.
So now, can you show the compilation again?
Compilation.
And the code now, sir.
Code. Yes. Closed it, but we can open it. Not a big deal.
So, so from this statement, you can say that in a single statement, you can put more than one assignment.
Like it is possible. It's bad thing to do. Yeah, it is possible. Because equal to is just an expression with a side effect.
So when it's that assignment value of k is going to be read. So in the brackets, it'll do j plus 1 first, then it'll assign that to I, and then the copying will.
And then increment happens, and then it will be assigned to k.
Okay, sir.
See, actually, I just want to illustrate some ideas using these things, but all these are bad pieces of code. You should never be using this kind of code when you write your programs.
Sir, sorry, sir. Can you show the output again? Yes, sir. Thank you.
All right. So now let's move on. Yeah. ABS. So now we will move to control flow statements. So let's, I want to pick up all the code associated with control flow statements. All right. Just give me a minute. Okay. So this is a program which computes absolute value of x. You know what is the absolute value of x? If x is greater than 0, absolute value of x is same as x. But if x is less than 0, then it is equal to -6. So let's run this program. So here on line 10, we are using this relational operator where we are checking if x is greater than 0. If x is greater than 0, then it's a true. It's true. So true means that expression returns 1. So true means a integer value 1 will be returned, and if it is false, then 0 will be returned. So in C, 0 is treated as false, and any non-zero value, be it -1 or 1 or whatever it is treated as true. And so there is this question, so shouldn't be using left and right parenthesis, shouldn't be using a block statement. It is not required. It is not required. As you can see, there is no ambiguity. If x is greater than 0, only this statement will be executed. And if otherwise, only the statement 13 will be executed. So it is not required. So if you have only one statement with no ambiguity, then there is no necessity for using left and right flower brackets. So let's compile this program, and we will see what is. So if you enter 4, you get 4. If you enter -4, you get the answer as 4. So here, so again, the important thing is in the if part of the statement, so there is one statement, and in the else there is another. So because of it, you have to, you are using, there is no necessity for putting left and right parentheses. And the question is, what if it is equal to 0? If it is equal to 0, then what happens is, you still go to statement 13, so -0 is 0, so so ABSX is 0. There are questions on is indentation required or it's not at all required. This is not Python, so you might as well write the code like this. This works perfectly. Okay, so GCC. So you can see it still works. So indentation is not an issue. So there is a question, what if we enter a character? If we enter a character, scanf returns an error. It will not read anything into variable x. Its ASCII value will not be read into variable x. No. But x may contain some garbage value depending upon that. Yeah, so either it can go to if part or to the else part. So indentation is always preferred. Like for example, on this editor, if I do format document, then automatically the code gets nicely formatted. So this is the right way to use the if statement. But let's say along with computing ABSX, you want to increment it by one more. Let's say in this particular case, if x is greater than 0, you want to increment x by 1. And if it is less than 0, then this is not ABSX function. It is some other function. And you want to say x is equal to x plus 2. So now if you see in the if block, you want to use two statements. Since there are two statements, we have to, it's a compound statement. We have to put flower brackets around it. It's a block statement. We have to put flower brackets around it. Now it is essential. Now you cannot do this. Now this doesn't work. If you do this thing, now it gives an error. Okay, so now already it gives an error because this if and the line 10, the if ends are on line 10 and x is equal to x plus 1 is the next statement, and you have a statement which starts with else, so it's a problem. Are you with me on this one? Let's say if I do formatting, let's say if I do format document, so you can see if I do a format document, what is happening is the statement on line 11, it goes to the if, and this is an if statement with no else. It's not necessary that if needs an else. Okay. And then 12 is a statement which stands by the statement on line 12, it stands by itself. And on line 13, you are starting a statement with else, which is, there is no such statement which starts with else. So because of that, you have a compilation error, and you can see the editor is showing this, no, this red line. So there is a problem. So what we do is in order to, so if you want to do, if this is what you want, this is how you should write the code. Yeah. Are you all with me here on this one? When to use flower brackets and when to use great. So let's compile the code. And so now when we compile the code, if x is equal to -4, 6 will be printed. In if x is equal to 4, 5 will be printed. Because we are incrementing x by 2.
No user. Sir, no, sir. You're still printing ABSX. So it will still print 4
statement. Okay, okay. Sorry. ABS. Thank you. Yeah, this is what I wanted actually. So now if x is equal to 4, then 5 will be printed, and if x is equal to -4, 6 will be printed. So x is equal to 4, 5 is printed, 6 is printed. Can line 18 be replaced by ABSX plus plus? It is possible, yes. Yeah, so, but you try it out and it should be possible. Whatever you are suggesting, it should be possible. So now let's look at some more code examples. Yeah. So let's look at this example. So this is, now we are in this particular example, instead of using if, we are using a ternary operator, n greater than or equal to 0. So this is an expression, and if this Boolean expression turns out to be true, whatever the expression value here, it can be anything, it will be assigned to this variable. And if this is not true, then whatever that is present here, it will be returned. This is what is called as a, so far in the code, you have seen unary expressions, we have seen binary expressions, but this is what is called as a ternary expression. What is a ternary expression? A ternary expression has 3 operands. So this is operand 1, this is operand 2, this is operand 3. Ternary expression. So the general form for ternary expression is op1 question mark, op2, op3, and if op1 evaluates to a non-zero value, then op2 will be returned, and if op1 evaluates to 0, 0 means false, then whatever the value op3, it will be returned, right? So if you want to think about it in tree form, evaluate op1, if op1, if it is not equal to 0, and if it is equal to 0. There are some questions, please hold on. And if it is not equal to 0. So if op1, if it is equal to 0, that means it's evaluated to false in C parlance, in which case op3 will be returned, otherwise op2 will be returned. And here on line 7, we have declared a variable called as flag. Flag is not a primitive data type in C programming language, but if you want to, bool is not a, and the type of flag is declared as bool. So bool is not a primitive data type in C. Int is a primitive data type. That is, it's kind of part of the C programming language, primitive data type, but not bool. Bool is kind of defined, and it is defined in this include file stdbool.h. It's a new data type that is being defined, and it is there in, and if you want to use the bool data type, you have to include stdbool.h. And so essentially here, what we are doing is we are checking if an input number, if it is greater than or equal to 0. If it is greater than 0, true will be assigned to flag. Otherwise, false will be assigned to flag. And we are checking if flag, that is, if flag is true, then the if part will be executed. Otherwise, the else part will be executed.
Sir, could you explain that again after line 12? What exactly happens?
After line 12 or line 12?
Like line 12 and after that also.
So line 12 is simple. So this n greater than or equal to 0, that is the expression of 1, it will be evaluated. And
is that like
if
a
it
test
evaluates to any non-zero value, non-zero means in C it is considered as true. 0 means it is considered as false. So if it is evaluated to a non-zero value, then whatever that is present at op3, in this particular case, at op3, you just, it turns out to be, we are using a constant called as true.
Is that like a test condition then? N is greater than or equal to 0?
Yeah, that's true. It's a test. It's a Boolean condition. Yeah, it's a Boolean operation.
So if true, then it will assign true. If false, then it will assign false. Then if will check.
See, I kind of used a bad example maybe here. So instead of true or false, it can be anything. So here, I used true, right, and false. Instead of true or false, it can be anything. If n greater than or equal to 0, let's say, so depending upon
So
the
you can
logic.
directly write printf positive and printf negative.
Sorry?
I'm saying if n greater than equal to 0, instead of assigning true and false, you can tell it to print it is positive or print it is negative.
Yeah, it is possible. You can just make a function call. Like for example, that's kind of a bit extreme, though we don't do it in real programs, but you can call any function here. So let's run this program and see what happens. And then what, Siddharth is mentioning, we will do after that. Let's compile this code, GCC. What is the name of the program? GCC CONT. So it's a positive number, minus 34, it's a negative number. But what is important is our friend Siddharth, he gave a very nice idea that, like the example that I have came up with, it's not looking, it's not very illustrative, but you can kind of, in fact, go a bit extreme and even do this. Let's see, I didn't try it, never, I think it should work. So if n is greater than or equal to 0, whatever that is present here, it's a function call, it gets executed. Let's see. Yes, it works. I have a question for you now. I don't need to remove flag. So what will flag contain after line 12 gets executed?
It will have 1.
It will not have 1. Maybe, okay.
Because it will be true in both the cases, right? Printf will return some value.
Yeah, it will printf will return some non-zero value.
The
But
number
let's say instead of flag being bool, let's say if it is int, what will flag contain?
It'll still be the same values that they printed out, right?
What will flag contain after line 12?
I think it will contain 1.
It will?
So it will contain the number of characters in the print.
Yeah. So what happens is if n is greater than 0, n is a positive number gets printed and the number of characters that gets printed is what printf returns. So that will be stored in flag. And if n is negative, then this n is negative number gets printed and the number of characters that got printed will be returned and that will be assigned to flag.
So could you show that once, like just see if you can make it printf flag also, then we can see that as well.
Yeah, sure, why not? Flag equal to %d/n. So 23 characters got printed. It so turns out the number of characters in both the cases is the same. So let's say I will make this positive into, yeah. So now it is 18 characters. Now it would be 23 characters. Are you all with me on this example?
So may I ask a question?
Sure, Shashwat, please go ahead.
Sir, in the ternary operation, you said that the op1, if it returns a non-zero value, it's considered true. So, sir, am I to understand that in a ternary operation, the op1 can return an integer value and it will be interpreted as a boolean? However, in an if statement, the conditional has to return a boolean value and the if statement cannot deal with integers?
No, not at all. So even in an if statement in the C, in the original C and in C, any non-zero value is considered as a true value and zero value is considered as false.
So, sir, hypothetically, if I put if 4 minus 2, it is considered if true and so on and so forth.
Yeah, that's true. If 4 minus 2, that is 2, it's since 2 is 4. So non-zero value, it is considered as true.
Understood, sir. Thank you.
Yeah.
So 1 second. Sir, is true considered a keyword here?
In this particular case, I think true is not a keyword. I think it is defined in std bool.
Yeah, with the bool operator, bool function.
Yeah, it could be a macro. True could be a macro, has defined true is equal to 1 or something like that.
Okay.
It could have been defined.
Now we tried printing and it gave hexadecimal 1. So
sorry?
We tried printing the value of the bool variable and we got hexadecimal 1.
Okay, and what happened? You got 1?
Yeah, we got hexadecimal 1, not just 1.
Oh, okay.
I don't know why. So can you define that using a macro?
I think you should just check stdbool.h and see how it is defined.
Okay, sir.
Yeah.
So when you link stdbool.h, if you use the preprocessor directive, then it will automatically assign true to 1 and false to 0.
See, linking is not the right word to use. Linking is different. Let's look at this program. This is COND-EXPR. The output of the preprocessor, I am redirecting it to a file called temp.txt. Let's look at temp.txt, Control O, temp.txt, Control F. True is not defined. surprised. So what happened to bool? Where is bool? Yeah, so here, this is, if you look in the STD, are you able to see my screen? Just these 3 lines. So here you can see true is in std bool.h, true is defined as 1 and false is defined as 0, and bool is defined, there is some other type called as underscore bool. Let's not get into all those things, but you know, if you want to use true, false, bool, etc., you have to use std bool.h.
Sir, I have a question. Sir, am I audible?
Just 1 minute.
Yes, sir. Sure.
Yeah, please go ahead.
So, sir, is there a way that, say, I want to make a function wherein any number we add, it will bring it down to 0. I want to make a function like that. So, say I add 30, enter the number 33. Okay, like you did. So, I want to check if it is greater than 0. Then I want to add a -1 to the integer and then repeat the process all over again. So, is this possible with bool?
Can you repeat again?
Yes, sir. So say I want to make a program in such a way that no matter what number I enter, it will repeat until it will get to 0. So say I enter 5. Okay. So 5 is greater than 0. So if number is greater than 0, I want the function to add a -1 to the number and go once again.
Okay, it is, yeah.
So can bool do that, or if else, or how do we do?
No, we will look into it. So keep that question, you will get an answer to it in some time. Okay, so bool is just a data type. It cannot do all these fancy things.
So,
yeah.
Is it possible to assign a value to 2 variables instead of just 1? Is there anything we can do about that?
What do you mean by that?
Using the ternary operator, using the ternary operator, I want to assign a value to 2. So if the first condition is met, then I can assign a value to A and B instead of just, flag or whatever.
Then you have to use the flag 1 is equal to flag 2 is equal to.
No, but I want them to be assigned different values. So like,
different
suppose I'm trying to find the maximum of 2 numbers, and I'm going to be like, okay, so max will store the highest number and minimum will store the lower number. So I'm putting it through the ternary operator to find which one is the bigger one, and storing the bigger one in max and the smaller one in min.
Let's try like max. I'm not sure if this will work. Let's say if we have 2 variables, A is greater than B, then I don't even need this. So it is already complaining max
I don't think it's going to work. So it doesn't seem to be, it won't compile it, I don't think.
For the sake of simplicity, we can make, I don't want to read anything from the input. So let's say A is equal to 4, B is equal to 10. There's an error here. An expression must be a modifiable value. Let's There is a compilation error problem. L value required, it is saying. Let's say some variable temp in order to make it happy.
So can you put
So
brackets
shouldn't it
around
be A greater than greater?
Like
A
this?
greater than greater than.
No, it doesn't matter because ternary will always want to return a value and it's not able to, it doesn't have any value to return. It's
Oh,
only
it
getting.
doesn't have any value to return. Yeah, yeah. That's an issue. Yeah, it's not. Yeah, I think it's not possible. It has to return a value. So when I just have these two assignment statements, I thought
Can you put a
comma
return after that?
separation. Yeah, this is weird. It doesn't work. Okay,
So
let's
can you put a return after that?
return after this.
In blocks.
You're driving me nuts, guys. I think it's not. I'm not sure. This is.
Sir, but doesn't an assignment statement also return a value?
No, but you have comma separated assignment statements, so it's not defined what it will return.
Excuse me, sir.
Yeah.
Sir, can you hear me?
Yes, yes. Yeah.
So can we just remove the temp is equal to part because we're not using it anyways, and then we won't need to use the.
No. Ternary operator wants to return a value. So there is no way, even if you remove it also, you'll have a problem.
Okay.
Yeah,
So
there's
you
a
need to
problem.
terminate return. You need to terminate the second return.
No, it's not working. It is expecting an expression, but we are using a block statement, so it
Sir,
doesn't.
this will end the program prematurely. It won't even go to the print statement, I
Yeah,
think.
it's not. It doesn't even go to the print statement. That's true because we are returning 0. It's not going to work.
So is it
Okay,
possible?
let's not confuse others. So it's a good idea, but I don't think what you're expecting will work. So if it works out, if you find a way of to make it work, let me know. Is it all right?
Yes, sir. Is it possible to put a ternary operator inside another ternary operator?
Yeah, of course you can do it. That's possible. Yeah.
Okay.
That's possible.
Okay.
Okay. So good discussion here. Couple of things I want to mention. Like lot of these syntax things like ternary operators, etc. They are there in C because C is designed long time back, and on ternary operator or plus plus I minus minus, all these things are there. I think way back then, 30 years back, 40 years back, they want to save on the typing time because the devices, the IO devices that they have to enter programs, they have some issues or something like that. So because of that, so C is designed to see that the effort required to enter programs is minimal. But nowadays, all these things, they are not at all relevant. So when you write code which is very clean and which is readable by you when you look at the code an year after or 2 years after, and the code is readable by others for using your code base to improve upon it or add new features.
Sir, may I speak?
Yes.
So I made it work by just putting the assignment inside the bracket.
How is it? Can you just put it in
I'll
the
put it
chat
in the
box?
comments.
Sorry?
I'll put it in the comment.
Yeah, put it
in the chat box.
Chat box. Let's see. Oh, this works now. This is because max is equal to A. So this is not what we want to do. We want to have multiple side effects.
Okay.
So this will work, but it's good though. It's a good effort. So yeah. So here, this is what I mentioned. A will be assigned to max, and this whole assignment statement, it has a return value because it's actually like an expression. So, and that value will be copied to X if A is greater than.
Sir, do we need to put the variable X in the beginning?
of the ninth line? Is it
Sorry?
necessary? Is it necessary to put the variable
So
x?
for me, multiple assignment is also working.
Like what? So in this particular case, if you don't want X, we can just leave it. It's not a problem. It will still work. So even this is also good. Okay, so because we are not using X anyway down the lane, we can ignore the return value.
Then we can add multiple statements, I think. This is what I said before. Now if we do, because it's not asking for a return.
See what you have.
Ternary still needs to return something, like the operator.
Did you try this one or? I'm seeing only half of it, Naman. Ah, okay. Now I saw the whole. X greater. Is it working? Naman, is it working or not? Let's see. Is this working?
Yes, sir.
It should work. No?
Let's see. I don't know what return value the whole thing in parentheses will give. It is able to compile. So it has two side effects. But what is the value written by this thing that is there in parentheses?
It is, let me check.
Return because it's a whole block, right? And we can test it. If we put temp is equal to, then we get an error, right?
Yeah, let's see.
It should be like it is not returning anything.
Yeah. So max, min, and
sir, hello.
Yeah. Just 1 minute. Let me try this out. Temp is 10.
So I think temp got the value of B, I think, in this. Because
So
temp
maybe
is
that
getting
parenthesis, it may have some kind of semantics. So
something's definitely
wrong. Sir, in the
comma
ninth line, there is an error.
Max equal to B, min equal to A.
Sir, yes, max B and minimum B all in the ninth line, sir.
The comma operator probably does that.
So what's the question now? This is okay, but I think yeah, temp is equal to -4. Okay, it has some semantics, but it seems to, yeah, this is what I was trying to do, multiple statements separated by a comma. It works, but what is the value returned by this whole thing that is there in the parenthesis? That I don't know. We should check in some manual somewhere.
So, but then temp also was printed as -4. So does that mean it returned -4?
Yeah, it looks like the case. It returned -4.
But why -4 and not 10? What was the segregation idea there?
I think the comma operator has semantics, like it does max.
Oh yeah, the comma might.
And then it throws
It'll
away
give the final output.
It throws away
Yeah, that's true. That's true. That's what I'm thinking. We don't know exactly the.
Yeah, comma semantics gives the final statement only. It ignores everything else. Yeah, at least that's how it was in C++. So.
Why did it give negative?
Should be the
4?
same. Because min A and A is -4.
Right. Okay, fine.
All right, good. So the time now is 3:45. You guys took all my time on this.
Sorry, sir.
It's a good discussion. Yeah, so what to do? I'm just thinking. Maybe I'll just show a couple of more example codes and then we will take a break for the lab, because once there are some ideas I want you to see, because once you check those ideas for the rest of the week, you can happily do your programming. So 15 minutes of my time, your time, it will enable you to do all the homeworks nicely. So I will take the class till 4. From 4 to 5:30, you can be in the lab session. Is it all right with you guys? Is it okay?
Yes, sir.
Thank you. So let's get going. So all good discussion. Yeah, let's see. So this is the code. Again, this code, either you can use the conditional expressions or you can use the if statement. If you read two numbers from the input, if A is greater than B, then max is equal to A, otherwise max is equal to B. This is a simple program to compute max of two numbers. And again, the point here is there is only one statement here, so you don't need to use left and right flower brackets. So let's compile this program and run it through. Uh, 23 minus 10, so maximum of minus 23, 10, maximum of A and B is 10. So we are all doing good. So this is as expected, no, not much surprise. But now let's look at one more piece of code, which is max of threes. So here we want to compute the maximum of three numbers. So if A is greater than B, so many times when you are trying to do these things, you can draw decision trees like this. If A is greater than B, so there are two possibilities. One is no and other is yes. So if A is greater than B, if you want to know what is the maximum, so you already know A is greater than B, so you check if A is greater than C, and you draw this decision tree. If this is no and this is yes, and if A is also greater than C, then max is equal to A. Otherwise here max is equal to C. On the contrary, if this is not the case, then that means B is greater than A. So what you do is you want to check if B is greater than C. So no, yes. And here, if B is not greater than C, max is equal to C and max is equal to B. So this is the decision tree. This is what is called as a decision tree. So when you guys get confused on the logic, drawing some decision trees like this will help you, arrive at the correct logic. And the important thing here is if A is greater than B, the whole statement from 11 to 14, it is a single statement. It is a single statement. So you don't need to keep the flower brackets. It's not necessary. It's not necessary to keep flower brackets. So although it is a good idea to do it, so if you see, we can put flower brackets here. And if I say format document, you can see that this whole thing is within this the if part. And so usually what happens is, yeah, so this is the indentation. All right. Do you understand this code? Are you with me here? The point I want to make here is this whole if statement, it is like a single compound statement. So you don't need to explicitly put it, make it into a block statement and keep it within left and right parentheses, left and right flower brackets. So you don't need to know what you are doing in the if part. It's not necessary to do it, but I would say it is better to do it because it makes the code readable. So that is the reason for this code. That is the reason behind this code. Are you guys with me here on this example? Are you with me? Can I go ahead? So there are a couple of questions. Can you, what if all three are equal? Then one of the, you check what if all three are equal? Nothing bad is going to happen though. So what happens if A is equal to, let's say if everything is equal, let's assume this. If A is equal to 23 and B is equal to 23, so this condition turns out to be false. So you enter the else condition and B is 23 and C is also 23. This turns out to be false. So you come here and you say max is equal to 23. So nothing bad happens. So it's all right. Rajeshi, you have a question? All right, if there are no questions, I will keep going. So max of 3s, this is also done.
Oh, sorry, sir. I accidentally had raised my hand.
Okay, no problem. So this is an important example, guys. So here is a code. So here, please check this code. So if y is not, so we are reading two numbers x and y. And so we are trying to, if y is not equal to 0, we want to do the computation from statements 10 to 13. And on the contrary, if y is equal to 0, then we want to say that there is an error. So there is a lot of discussion happening in the chat. Could you please focus on what is happening in the lecture? It could be distracting for everyone. Just wait for 10 minutes. There are a couple of ideas I want you to understand. And after that, I will answer your questions. So this is an important problem that we are looking at. This is what is called as a dangling else problem. So what we are doing here is we are checking if y is not equal to 0. Then we want to do the statements from 10 to 13. And within statements 10 to 13, we want to check if x is greater than 0. If x is greater than 0, then only we want to compute square root of x divided by y. Our idea is by the time we come to statement 11, x should be greater than or equal to 0. And so this is, put it another way, and y is not equal to 0. These are the two things that we want to check. And so here, if y is not equal to 0, then if y is equal to 0, then we say, there is a problem. If that y is equal to 0, we don't want to do the computation. So let's compile this program and see what happens.
Sir,
so if we enter,
I have a doubt.
Yeah.
Sir, shouldn't we put two flower brackets? Like there are two if statements, right?
So the idea here is this if is supposed to be, our mental idea here is the if here, it is the if part of the outer if. There is an inner if and outer if. The inner if is the part of if part of the outer if. And there
so
is
the
a
inner
question,
if is
what
part
is
of the outer if, right?
Sorry?
Right, sir. The inner if is part of the outer if, right?
The inner if is part of the outer if. So can you, if you hold on for a moment, I will clarify your question. Is it all right?
Yes, sir. Yes, sir. Yes, sir. Of course.
So here, let's say if y is not equal to 0, let's compile this. So this y not equal to 0 means, like for example, if y is equal to 2, then this condition turns out to be true. If y is equal to 0, this condition turns out to be false. Right? So let's clear this and compile the code. GCC minus link math, because we are using square root. So if x is equal to 12 and 0, so if x is 12 and y is 0, so since y is equal to 0, this condition is false. This condition is false. So the control should come to the else part, and we have to print this error y is equal to.
Sir, excuse me.
Yeah.
Sir, I think what is happening is that the else is associated with the inner if.
Yes, exactly. So you got it. So this is the error that I'm trying to, I thought I will point out, but many of you have already noticed it. So when we supplied the 0 as input to y, what happened is the control didn't go to this part, because what happened is, this else is associated with this inner if. So if you look at the else part of the outer if, there is no else part for the outer if, and hence there is no output for this program. And this is what is called as a dangling if problem. And the way the semantics, the C assigns the semantics is associate else with the closest if. And if you see, the else here is, the closest if to this else is this if is the inner if. So else will be associated with the inner if. And if you do the formatting, if you do auto format, clear format document. Yeah, if I do the format document, this becomes now clear. You can see, so this is the whole body of the if, and so if this condition is false, then the control goes to the statement after 16, after line 16, and after line 16 there is no statement is there. So it that's what it is. The program terminates. See, in order to make the else associate with the outer if, what we have to do is we have to modify this program. Okay, so we say, the if part of the outer if starts from here. So now it becomes very clear. So now what happens is if y is equal to 0, then this condition will be false, and you go to line number 13 and you print that y is equal to 0. On the contrary, if y is not equal to 0, then you go to the statement, if statement that is there on line 11. Are you with me here? Just compile the program. I think we should stop here. I thought I can cover couple of more ideas, but it's okay. I think we should stop here. Time is 4 o'clock. You should start your lab. So, okay. So there are a few more examples we have to see, but we will see these examples in the Monday class. So your TS will let you know what you have to show in the TS. So let's conclude today's session. I'll stop recording.